We are going to... Please?
Can I share my screen or not yet?
Now we are going live stream.
Okay.
Now we are live streaming on YouTube. You can find the YouTube channel on the detailed program on the ICCSA site. So we are going live stream, and we are going to start in a minute time. I will be the chair and the technical assistant of this session. So maybe we can wait another minute so as to see if other participants are going to join us.
Okay.
If you agree, of course.
Yeah, okay, no problem.
May I ask you also to turn on the camera?
Okay.
Welcome to Ezeldin Sherif.
Hello. Thank you so much.
So we have the three speakers scheduled for this session. So whenever you want, we can start. But I suggest to wait 5 minutes to see if other participants are going to join us, if you all agree.
I agree.
Okay. So we are going to start this session. The first presentation is entitled voice gender recognition using acoustic features, MFCCS and SVM. The authors are Fadwa Abakarim and Abden Abanau, and the presenter is Dr. Fadwa Abakarim. So the floor is yours. If you want to share your screen and your presentation, we can start.
Okay.
Okay, now we can see your screen.
Yeah, okay.
We can see your screen. And now we can see your presentation. So the floor is yours.
Can you hear me? First, can you hear me?
Yes, we can hear you.
Okay,
Loud and clear.
I start. Okay, I start. Good afternoon, everyone. I will present the voice gender recognition system using acoustic features, MFCCs, and SVM. This work is realized by me, Fadwa Bakarim, and Professor Ibn Abnau from National School of Applied Sciences, Ibn Zohri University, Agadir, Morocco. And let's start. A voice gender recognition system is one of the most relevant and useful systems in applications such as sorting telephone calls by gender, security systems, and human-machine interaction. In this work, we combine acoustic features and male-frequency capture coefficients in order to test the performance of the proposed system. Four different databases are used with different accents, languages, emotions, voice pitches, diseases, and ages. Moreover, only half of each database is used for training and the other half for testing in order to determine whether the system can reach satisfactory results. So the presentation is organized as follows. The first thing I will present the architecture of the proposed system. Then I will present the preprocession part. After that, I will describe the different approaches used for feature extraction and classification. Later, I will present the results obtained in our study. And finally, I am going to conclude the presentation with a little conclusion. Now I am going to start with the architecture. In our study, we used a three-step process to identify the voice gender. The first step is preprocession, in which we remove silence from the input voice signals to compress their length using zero crossing rates, also called the ZCR. The second step is feature extraction, in which we use two different approaches. The first approach is to extract acoustic features from the input signals by calculating the mean frequency, median frequency, etc. In addition, the second approach is to extract FCC's features. Finally, the last step is classification, in which two methods are used. The first method is to determine a threshold from the acoustic features of the training dataset, and the second method is one of the widely used classifiers in the field of speech recognition, the SVM model. Let's start with the first step, preprocession. Signal preprocession is an important step, of course, in speech recognition. It allows us to compress the signals and to keep their qualities by removing the useless information. In our study, we used the zero crossing rates, ZCR, method to detect the invoiced parts of the signal and remove them to obtain a 100% voiced signal. As we can see in the figure, when ZCR is high, the speech signal is unvoiced, and when it is low, the speech signal is voiced. The following figure presents the speech signal before and after using ZCR. And the second step is feature extraction. There are several methods for extracting important information from signals. Among them are acoustic features and male frequency capture coefficients. We will start with the acoustic features. Acoustic features are a set of properties that identify the voice, including the frequency features that are extracted after transforming the signal from the time domain to the frequency domain. In our study, we extracted the following 11 features: the mean frequency, standard deviation, the median frequency, the first quartile, the third quartile, the interquartile range, the skewness, kurtosis, picture entropy, spectral flatness, and mean voice fundamental frequency, also called F0 or pitch. Now let's move to the second approach, the mean frequency capture coefficients. The mid-frequency capsule coefficients is one of the most commonly used methods by researchers for speech recognition. Since speech is a non-stationary signal, short-term spectral analysis is the most common way to characterize the speech signal. In our study, we obtained 14 mid coefficients by following the steps in the figure. And the classification is the next step that comes after feature extraction. The choice of a classification model is very important as it affects the final decision and the performance of the system. In this study, we use two methods of classification. The first one consists in classifying the test signals by using a threshold based on the average of the training dataset features, and the second one is support vector machine model, SVM model. Let's start with the threshold. The frequency features help the machine to differentiate the male voice from the female voice, since the frequency data of the female voice is higher than of the male voice. Therefore, we calculated the mean value of the training dataset features for male and female. As a result, we obtain a threshold if the mean value of the test signal features is above the threshold, it is a female voice, and if it is below, it is a male voice. This classification approach is only valid with frequency features and not with MFCCs. Support vector machine, SVM, is one of the most powerful classifiers in the field of speech recognition. SVM supports binary classification, and in this work, we have the female class and the male class. SVM goes through two steps. In the first step, it is very important to choose a kernel function. We choose the radial basic function, which performers allow to hide the motional feature transformation. Then in the second step, a maximum margin hyperplane is constructed to draw the decision boundary between the classes. To test the performance of our work, we used 4 different databases. Let's start with Repossession. It is a widely used database for speech emotional recognition. It contains 14 audio files in WAV format with a frequency of 48 kHz, recorded by 24 authors, including 12 male and 12 female. The database is composed of 8 emotions: calm, happy, sad, angry, fearful, surprised, neutral, and disgust. The language of the audio files is English. This database is chosen to test the performance of our system with speech signals having different tones. And the second one is SVD. It is a widely used database for voice pathology detection. It is a German database which contains a set of voice recordings from more than 2,000 people, including males and females of different ages. The length of each voice recording is between 1 and 4 seconds with a frequency of 50 kHz. The database contains 71 types of pathologies. The SVD is chosen to test the performance of our system with pathology speech signals. And the third one is CMU_ART database. It is widely used for voice gender recognition. It contains 1132 audio files in WAV format with a frequency of 32 kHz for female gender and 1138 audio files in WAV format with a frequency of 16 kHz for male gender. The language of the audio files is English. We choose to test the performance of our system with this database because it is commonly used by researchers for voice gender recognition. And the last one is the Amazigh speech database. It is a self-created database that contains 300 audio files of numbers from 1 to 5 in the Amazigh language: Yan, Sin, Krad, Koz, and Smooth. The length of each audio file is between 1 and 3 seconds with a frequency of 60 kHz. A total of 60 people participated in the recording, including 30 male and 30 female. We created this database to test the performance of our system with a new type of language and accents. As shown in the following table, we divide the database into the first half for training and the second half for testing. Table 2 shows the accuracy rates of voice gender recognition using acoustic features. As mentioned before, a threshold was created to perform the classification. We obtained good results using this classifier, but they are not as good as those obtained in using the SVM classifier. Table 3 shows the accuracy rates of voice gender recognition using the MFCC's features. The threshold mentioned in Table 2 is only valid for frequency features. Since females have higher frequency information than males, only the SVM classifier is used for the MFCC's feature. We can see in Table 3 that the results obtained are lower than the ones obtained in Table 2 using the acoustic features with the SVM classifier, but it's not the same case for the CMU_ARCTIC database. After using the acoustic and the MXCC's feature individually, we combine them to see if this would provide better results than the ones obtained in Tables 2 and 3. Table 4 shows that the Amazigh speech database reaches an almost 100% accuracy for the recognition of male and female gender. The same goes for the CMU_ARCTIC database, while the SVD and Repossession databases achieve more than 90% accuracy. Table 5 presents the results obtained in our study with the results of other existing studies. In this work, gender voice recognition goes through 3 steps: preprocessing, feature extraction, and finally classification. First, CCR is used to compress the input signals by removing silence. Then we extracted the acoustic and AFCC features. Finally, we use a threshold and SVM as classifiers. As a result, although we use unfiltered signals and different databases with different ages, accents, languages, emotions, our system performed perfectly, especially when we combine the acoustic features with the MFCC coefficients. The accuracy rate was almost 100% for the Amazigh speech and CMU_ARCTIC databases, as well as over 90% for the RAPTIS and SVD databases. The execution time was fast in the second and third steps, but the pre-processing part takes more time. The system can, for example, be used for human-machine interaction, security systems, and digital advertisement by changing the graphical interface, for example, if the detected voice is male or female. And this is the references. And finally, I would like to thank all organizing committees members of the 22nd International Conference on Computational Science and its Applications, and thank you for your attention.
Thank you for your very interesting presentation. I don't know if there are any questions from the audience here in presence.
Thank you.
In which language developed the computational experiments run?
Okay. Did you hear the question?
No, I can't hear it.
Okay, so the question was, in which language did you run this kind of analysis?
Which language? I used German language and English language and Amazigh language. It's a language that is in here in Morocco. There are 3 types of Amazigh language. Tarifit, it is in the north of Morocco, and Tamazight, it is in central of Morocco, and Tashlhit, it is in south of Morocco. So, yeah.
But I mean the computer language, did you use
Sorry.
to implement the...
Sorry, I totally misunderstood the question. Dr. Guerrero asked actually which computer language. No, I misunderstood the question, so I apologize for the inconvenience.
No, it's MATLAB. I used MATLAB.
Okay.
Thank you very much for your answer. There is another question. If you want to come here and ask your question. I will be glad to leave you the floor so that I won't misunderstand your question again.
Thank you. Thank you for your presentation. I have one question. How do you think, have you differences between male and female, like indicator, you calculated the indicator, as I understood, and do you have some differences between different languages? I mean, maybe this indicator could be different for Morocco and German languages, or how do you think, or it's very it's not dependent for language or nationality.
For the databases that I use 4 different databases because the first one was the ECVD database. It's a pathology database. It's based on pathology voice signals, and I use the database to see how the machine can react over over pathology signals, and I see that pathology I can't control. I can't control the algorithm over pathology voice signals because the tones of voice they are react differently. For example, the frequency of male is from 85 to 180 hertz, while that of a female is from 165 hertz to 255 hertz. But with pathology signals, the male voice are not always from 85 to 180 hertz. I don't know if you understand me or not, but also for the emotion signals, I have happy signals, sad signals, for example, also neutral signals. They are not reacting the same thing. That's why here in the accuracy rates, always there have this. It's emotional database and SVD. It's pathology database. It's always having the most inferior rates. But for CMU, Arctic, and Amazigh database, it's having the most accuracy rates because they are normal signals. But for RevDes, it's emotional. So the signals are reacting differently. I don't know if you understand me or not. It is clear now or not?
I mean that maybe for male and female voices in different nationalities, we have different indicators. I mean, but I understood that you have different frequencies, so it's difficult to say it influences it for accuracy or not. Thank you. I understood your answer.
Thank you.
I want to
come here. We have another question, then we can proceed with the following presentation, please.
only. Do you have tried some another different kernel to try the support vector machine?
No, I just no.
The radial kernel, no?
Can you please repeat your question? I didn't understand it.
I think you have tried the radial basis kernel, no?
Yeah, radial basic function. Yeah, RBF kernel. Yeah.
And you have tried a different kernel?
No, I just try RBF kernel.
Okay, thanks.
And you're welcome.
Thank you again for your presentation. And
thank you so much.
You're welcome. And we go on with the next presentation, which is entitled Uncertain Integration and Composition Approach of Data from Heterogeneous WOT Health Services. The authors are Sura Bulares, Salma Sassi, Jamal Benslimani, and Sami Faiz. And the presenter, this speaker, is Sura Bulares, if I am not mistaken. So the floor is yours. You can share your screen and start with your presentation. Can you hear me?
Hello, can you hear me?
Okay, now we can hear you.
Okay, I will share my screen.
Can you share your screen?
Yes, I will. In fact, I can.
And if you move your, okay, now we can see your presentation. So the floor is yours.
Like, okay, can you hear me? The voice is clear? Okay. Uh, so, hello everybody. I will present my subject entitled Insertion Integration and Composition Approach of Data from Heterogeneous SWOT Health Services. The subject can be looked at under the following headings. First, we have the context, motivation, state of the art, proposition, use case, and finally conclusion. So the usage of electronic health record, wearable devices, and health applications has expanded in popularity. So in the context of what shared health data may be untrustworthy for a variety of reasons. Uncertainty can be caused by heterogeneity, incompleteness, unavailability, and data inconsistency. So for these reasons, we aim to model the uncertainty, provide a probabilistic approach for composing uncertain health connected data and computing the probabilities to deliver the final degree of uncertainty, and we aim also to propose a method for parsing typical what objects into a new programmatic form that mimics the uncertainty of health data. So IoT aims to minimize the gap between the virtual and physical worlds, as well as to provide connectivity. On another hand, the 3W allows the adaptation of standards and protocols that have been adjusted for the sake of what. So, as it said, the Web of Things is the glue in between. In fact, the Web of Things seeks to counter the fragmentation of the IoT by using and extending existing standardized web technologies, by providing standardized metadata and other usable technological building blocks. The 3WC what enables easy integration across IoT platforms and application domains. So, what is applied to multiple domains such as cities, agriculture, and health? IoT and what ensures the personalizations of healthcare services by maintaining digital identity for each patient. What healthcare technology is set to revolutionize the healthcare industry to the next decade, as it has a great potential and multiple applications from remote monitoring to medical integration, what-based healthcare systems play an important role in the development of healthcare information systems. So the dependency of healthcare on what is increasing day by day to enhance the access to care, strengthen the quality of care, and finally reduce the cost of care. So a better healthcare system should deal with real-time health monitoring, early detection of critical health condition, and should provide home-based care instead of costly clinical care. So these information or data will be used to integrate and to be composed for analysis and decisional process. However, having the huge large-scale amount of data coming from multiple and heterogeneous sources will cause many challenges, such as incompleteness, redundancy, imprecision, and contradictions of these data. So, a new paradigm will appear, which is uncertainty that describes a situation which involves unknown or imperfect information. So in order to clarify this problematic, let's take the following example, where a patient uses what services and connected things to facilitate the decision about his status at different moments of the day, as well as at different places during his work and home activities. So he uses what devices at home, at the company, and when practicing sports to self-monitoring his health. He used at home and company what devices to measure temperature. At the same, he used what health devices band to track the daily activities and life cycle data. So to have a practical, comprehensive view, the patient wants to integrate his blood glucose together with each context. The captured information are rendered to the doctor in order to notify him predictably with the state of his patient. So we have here different data captured from each context, and these data are redundant, such as in the context A, we have here marked in red redundant information, and in blue contradictory values. In context B and C, we have here contradictory information marked with green and incomplete values. So for the doctor, what would be his or the best decision for him with this challenge of uncertainty? So when dealing with the data uncertainty in what health services composition, the following challenges arises, such as the challenge how can the heterogeneity of values provided by different what devices which are not equal because they exist in different contexts can be managed. How should data that represents the same device be handled in terms of redundancy, contradiction, and incompleteness? And how should the value supplied by the various what devices be handled if they are not equivalent since they are situated in separate places such as home and workplace and have varying measurement accuracy. So before passing to the proposition, as a pillar work, we present a set of work that have been done to present heterogeneity in the context of the web and what taken a note that taken or not into consideration the uncertainty. So our previous work that have been done in 2018 that proposed an approach for modeling, representing, and reasoning navigating the uncertain web resources in the context of the web of linked data. The work of Kangpen and Parshant Goswami in 2018 also presented a method that applied semantic web technologies to integrate the health data and home environment data from heterogeneously built services and devices thanks to the web ontology language. The work of CEO that have been done in 2018 in order to deal with the or propose a common format and information fusion model for the complementary aggregation and abstraction of logs to deal with the heterogeneous sources. Our approach aims to deal with uncertainty, and we have here the architecture that is presented in 4 layers, such as the data, the composition, the person, and the utility application layer. Sorry, the first layer is the uncertain resource layer. We have here a set of data. The healthcare domain following various domain allows the variety of data and the prolific knowledge for the better analysis experience. All the data here are redundant, uncertain, heterogeneous, and highly scaled. So the integration and the composition become difficult process. For that reason, we propose in the second layer, which consists of the person layer, this process detects JSON LD files content that has been changed to probabilistic JSON LDPX and then parsed by the send-to-parse class into JSON LD format. So it will specify if according to the grammar syntax, then proceed to the process JSON LD, and if it's not a valid format, it will block the action or the person method. This third layer consists of the uncertain data composition. And the smart home and work environment data are also considered that as health-related sources, since they are tied to a person's health management. They proposed a certain composition technique in this layer combines health data services with what? Home and work services in the presence of data uncertainty. So it's necessary to integrate and collaborate personal health management data with home and work context. For that reason, we aggregate, the final response will be the aggregation of the multiple node or inserter node. Each inserter node could be with type int or mux. And we apply for each node a different formula that's represented in this as and the final response will be the aggregation of all the inserted node. The final layer is the utility application layer. This layer could be used by the doctors to suggest an appropriate treatment for the patient and to alert the patient with the details about his state and with the adequate treatment. So as the type of application, we have the health data, visualization, analyzation, and alerts, etc. So the motivation example that has been presented previously focus on the patient in different contexts at home, work, and when practicing sport. So the what devices provides different data values in each context. The main challenge of this paper is to resolve the data uncertainty issue and return the final degree of uncertainty to make an adequate decision for health patients in each context. So this table here present or describe the data value during 1 week provided by what devices for blood glucose, what device of temperature, and what device for steps in each context, work, home, and sport. So we have here two representation of web resources or probabilistic representation values that are parsed to compute the final degree in order to make the adequate decision of health patient. And we apply here the three formula for each node and for the aggregation of the final response. So to conclude, here we presented an uncertain approach for modeling uncertain health what data. We proposed an algorithm to parse data from JSON-LD to JSON-LDPX. We demonstrated an example to show patient health in different contexts, and we give the transparent view of data uncertainty to doctors and provide them with a better experience to make the pertinent decision. So thank you for your attention, and the floor is yours for any question.
Thank you very much for your presentation. It was very interesting. Are there any questions from the audience, from the room, or from the virtual room? Okay, so thank you very much, and we can proceed. We can go on, and the next presentation is entitled Managing Non-Functional Requirements in Agile Software Development. The authors are Ezeldin Sherif, Dr. Walid Elmi, and Professor Dr. Galal Hassan. The presenter is Ezeldin Sherif. So if you want to share your screen with us, you can. The floor is yours. You can start whenever you want. Thank you very much.
Okay, sure. I will share my screen right now. Can you see my screen right now?
Yes, we can see your presentation.
Okay, nice. Hello, my name is Ezeldin Sherif. I'm one of the authors and the presenter of this research paper entitled Managing Non-Functional Requirements in Agile Software Development, along with two authors, Professor Dr. Galal Hassan and Dr. Walid Helmi. The outline of the presentation is we're going to talk about the introduction, a brief summary of the Agile. Next, we're going to talk about the requirements engineering challenges in Agile. And then we're going to focus more on the solution that handled the non-functional requirements challenge. And then we're going to provide the conclusion by the end of the presentation. Let's start with the introduction. Basically, Agile means agility or adaptability or flexibility. ASD, which stands for Agile Software Development, became popular in the recent years. Basically, it uses iterative incremental development method to develop selected functions based on the user need and business need. By the end of each iteration, we provide a running system that actually can go on live production for the user. However, Agile focuses so much on the working software but give less focus on the non-functional requirements, or in other words, the NFRs. This will cause increased more time and more money, cost, and longer time to the market, and much more damages that could happen because of having less focus on the non-functional requirements, which is our focus on this presentation. Now, the challenges. We have many different challenges in the Agile requirements engineering. We have 16, to be specific, across 15 different research papers. Now, as you can see from the table, neglect of NFRs, which is non-functional requirement, is the number one on the list. It was mentioned on different papers, 14 out of the research paper, and this shows us an indicator that the NFRs is actually a hot topic in the Agile requirements engineering. Along with, at the same rate, is the minimum documentation in general. It's also mentioned in 14 out of the 15 research papers, which is also one of the dominant topics to be handled as a challenge in Agile. Now, we have other different challenges, of course, but not on the same impact as the first two. Now, let's focus now on the solutions. Now, the research paper focuses on the NFRs, the non-functional requirements. We gathered for the past 10 years or the past decade, what did the others do regarding the NFRs in different perspective? And we found 17 solutions that handle this, and then we categorized each one of them. For example, now in this table, as you can see, we have 4 different methodologies. We have 3 different methods. We have 3 different tools. We have 2 different frameworks, and so on. Now, let's look at the solutions. This table will show you the methods and methodologies. Those are 7 solutions out of the total of 17 solutions. Now, as you can see in here, we have the norm map, the NERV, the mid-off, the SIP, the decision tree, the ACRUM, and the sensor. Now, we include the type of the solution in each one. Like, for example, the norm map is a methodology, the NERV is a methodology, the third one is a method, and so on. Now, regarding the item itself, we put different items that is commonly used and found in most of the papers, and then we see, does it include in the solution or not? And this means yes or no. Yes means it's involved in the solution of a particular research paper, or no, it's not involved. Now, if you take a look at them, now we have the different cycle, or the different phases and activities throughout the software life cycle. For example, does the solution include informing client meaning of NFR? Does it handle function requirement? Does it elicitate NFR? Does it analyze the NFR? Do we link the NFR with function requirement? Do we model it? Do we recommend it? Do we plan it? Do we schedule it? And so on. And the next table is the rest of the 17 solutions. But since they are only not much number, like for example, the 2 are mentioned 3 times, the guideline is mentioned 1 time, which is the type of solution, the framework is mentioned twice, and now we use the same type of items, the same one we used in the previous table. And the same question applies. Does it include in a particular solution or not? So due to the time of the presentation, we will focus on this table, the 7 solutions regarding the methods and the methodologies. So let's take the first one, for example. Now we have the norm map. The norm map stands for non-functional requirements modeling for agile processes. This type of solution is a methodology. The purpose of it is to identify, link, and model NFRs. Basically, it added 3 main enhancements. It had the W8 user story card, and the W stands for the what, the who, and the what, and so on, as we know it. This is an enhancement to the current user story. Number 2, it links the functional and the non-functional requirements. Third, it provides an agile requirements taxonomy, which is divided into 2 items, the functional and the non-functional. The validation that used in the norm map to validate their solution, they basically used 2 data sets. The drawbacks, in my opinion, they basically did not validate it using a real-life or real-world agile projects, and it contained many steps. The next one is the NERV, which stands for the non-functional requirement, elicitation, reasoning, and validation. So basically, this is the purpose of it: elicitation, reasoning, and validation. And the type of solution, it's a methodology. The description, basically, it added 6 new artifacts to the cycle, which is elicitation taxonomy, the NFR US Com card, reasoning taxonomy, quantification, trigger card, and the agility index, which stands for NAI. This is basically the proposed idea from this paper. Of course, they used for their validation 2 case studies. However, the drawbacks is by adding 6 new artifacts, it may conflict the Agile manifesto objective, which to keep it simple and minimum regarding the documentation and the simplicity itself. In addition, did not validate using a real-world Agile projects to have maybe better results or better picture. Next is we have the me-do of V. Basically, it stands for the method for elicitation, documentation, and validation. The type of solution, it's a method. It basically focuses on the elicitation, the documentation, and the validation of requirements in Agile. Basically, it contains 3 phases. Phase 1, basically, we set the project objective with a business goal by deep understanding of the customer values. Next, it elicitate and document the requirements. And the last phase is basically performs requirements analysis, specification, and validation. Taken in consideration that phase 1 is carried out only once at the start of the project. However, phase 2 and phase 3 are carried out again in each iteration. Now, regarding the validation, basically it used one real-life project, which is good. The drawbacks, in my opinion, basically it's much more formal documentation is needed in order to specify the requirements. Now, next is the CEP, CEP, which stands for capturing, elicitation, and prioritizing. Basically, it's a type of solution is methodology. Basically, it's an automated framework that captures, will elicitate, and prioritize a non-functional requirement from requirements document that contain images. Basically, it's the focus is imaging using OCR. It converts the images into readable text format. And this is the way they elicitate non-functional requirements from digital documents and images. Now, the validation, they use data sets. The drawbacks is basically they don't use the real-world Agile projects. Next is the decision tree. Decision tree is basically a methodology. It's an extension of the SIP that we just mentioned a few moments ago. Basically, it's a simple decision tree to make prediction using historical NFR's data. Basically, if the non-functional requirement appeared 3 times or more, they are most probably will be predicted in the future iteration. So this research focuses on the number 3 using a decision tree. This is their proposed solution. Regarding the validation, they use the data sets. The drawbacks, they did not validate using real-world Agile projects. The scope of the solution is only focused on prediction. That's it. Nothing else is included, which is, I think, it's a little minor or too little regarding the solution. Next, we have the sensor. The sensor stands for the structured elicitation of non-functional requirements. The type of the method, the type of the solution is method. The purpose is to elicitate a non-functional requirement. Basically, it involves 3 main steps. Step 1 is preparation, which basically a business case presentation. A workshop is next, which is a series of short brainstorming sessions. And the last step is the follow-up, which is basically analyzing an NFRs and introducing improvements. Now, regarding the validation, basically it uses case study. Regarding the drawback, the scope is also limited to the elicitation of non-functional requirement and has nothing else to do with the rest of the cycle as we know it. In conclusion, basically, Agile is one of the hot topics in software engineering. There are many challenges regarding requirements engineering of Agile, such as ignoring a non-functional requirement or having less focus, let's say that, and the minimal documentation. In the past decade or past 10 years, we provided and we displayed right now the 17 solutions. We focused on 7, which is basically the 7 methods and methodologies. in the presentation. The rest of them are explained in the paper. In the future work, basically, we're going to provide one solution that covers different aspects regarding the cycle, the main aspects of the cycle, in our opinion. Basically, the NFRs, or the non-functional requirement elicitation, analysis, documentation, validation, and recommendation. And that's it. Thank you.
Okay, thank you very much for your presentation. Are there any questions about this presentation from the audience? Yes, we have one question here. So, please.
Could you please show your site number 6?
Excuse me?
Could you show your site number 6?
Okay, sure.
Your slide. No, you have a slide when you show the Agile, about Agile, before maybe. Yes, 5, number 5.
Yes.
So you choose some challenges in Agile requirements. So why you think that you choose these requirements from the list?
Choosing
what is the methodology of choosing the requirements?
I don't understand your question. Can you repeat it?
You choose some challenges in Agile requirements engineering. Yes?
Yes, you're talking about the 16, correct?
Yes. Why you choose these 16, this list? I mean.
Okay. Yes, I understand your question. Regarding those 16, those are the one that I found during the research and for the past 10 years. Regarding those mentioned papers, the 15 research papers. If there was more challenges, I could have added, but I didn't find any more.
And what is the methodology? Why you choose some requirements for analyzing?
Why did I choose?
Yes. So who put this yes in this?
Oh, okay. Yes, I understand now. Regarding the yes, this is myself. I put it. Basically, when I see the paper, when I read the paper, I compare it to the 16 challenges. So if the neglect of NFR is included in, for example, reference number 5, then I put yes. If it's not included, then I just put a dash. Basically, on what's written inside each paper or each reference of those.
Okay. Did you share your this table with other experts, or it's just your own opinion that it's right? That
I basically shared it with the two other co-authors.
Okay. Thank you.
You're welcome.
Thank you very much. And are there any other questions from the audience, from the virtual room? Okay, seems to me that there are no more questions. So thank you very much to all the presenters and to all the participants to this session for their contribution, for their questions, for their comments. And I sincerely thank you, and I wish you interesting ICCSA conference with us in the next few days. So thank you all very much and good afternoon.
Thank you.
Now we will have goodbye. Now we will have a pause and a break, and then we will start with the next session at approximately 4:20.
Now it's open.
Can you hear me?
Are you listening? Okay. 1, 2.
Yeah, okay, now I speak.
Here we are.
Yeah, hello.
Hello. Hi,
Okay,
Michael.
so perfect. You can hear us?
Yes, I'm hearing you. Are you going to help me?
Yes, you are the second
Okay.
presenter, right?
Night.
No, you are third presenter.
And we have a video.
We have a video here.
I sent my video to Michele to my presentation, but there are some other colleagues that are sharing their screen. I hope it works.
Yes, Ana Clara, we are managing.
The only thing when you show the screen with the video, you should enable the audio for the system. There's a little.
Yes, this is a point. Explain how to share not only the screen, but also the...
Let's try now.
Yes, we can try just to be sure.
And we must also explain this to the other presentations. How to share not only the video, but also the audio, because it was not working.
Colleagues, good morning from Brazil. I'm Professor Ana Clara.
I can hear you.
Okay, now.
So like I'll share.
And you have to tick this box.
Okay.
This way the audio from the video will go on screen.
Okay. Okay, so you see this?
Agora from Federal University of Minas Gerais. I'm presenting a case study. Yes, I'm seeing and listening. It's
okay.
Okay, perfect.
Yes, and I know that there is another presentation, another person that's presenting, that's Ashley, she's already there, that she will also share a video, but from her computer. So if you can, hi Ashley, so you can just explain her how to do this, because she will use the same system, but the video is in her computer.
Yeah.
Which paper is she going to present?
The final one.
The final one.
The last one.
But she can also share a link with you, so that if we have any problem, you can just use the link and share it from there.
Actually, try to share your screen with the video on.
Yes, I will try.
And when you click screen share and you go in the window in the pop-up.
I'm not the.
In the pop-up, if you go the bottom left, there is a little box. You should tick the box. It's a like share audio from the system. Can you see that?
Yes.
Okay, just that. Okay, just a few minutes and we'll be starting.
Hello, everybody. I am Ashley Adelaide Rosa.
Joia, Ashley, dá para ouvir. Pode parar, joia. It was nice, so it will be okay. Because in the previous sessions where we were, one person was not able to present because of these issues of digital meetings that are not so easy as we wanted them to be. But I believe it will work, okay? And let's see, Camila is already there, Ruben is already there, and Felipe, Chico is already there. I believe he's the first one to present. Let's check the list.
Like I guess first one is Francisco Enrique de Oliveira.
He's there.
Yeah. Maria do Carmo.
The second is Rubens, I believe, the presenters.
Like
Camila or Rubens.
I think Camila.
Camila and Rubens are there.
Okay.
Okay.
Then Ana Clara.
Then it's me. Hi, Camila.
Okay.
Then it's me, and after me, Ashley.
Okay.
I believe we can speak Portuguese in this session, can't we?
Only understand you. What go on?
I propose to speak Portuguese.
And Ana Clara,
yes.
You are moderating the session on Wednesday at 4:40.
Okay.
4 p.m. This will the one when I'm presenting. Okay.
Ah, okay. The one you're presenting, I will moderate. Okay, so you moderate today.
Yeah.
Okay, thank you, Michele.
I'm not sure if the program is updated on the website, but just
I believe not. It's a little bit confused, but I believe as it's Wednesday, we have time to organize it. Okay. So 1 minute, people.
Okay.
Chico, are you there, Chico? Vou falar português para ver se ele acorda. Ô, Chico, é o seu primeiro. Pior que eu nem falo português, né? Eu falo mineirês.
A gente deixa a nossa câmera ligada enquanto os outros estão apresentando, ou é melhor desligar para não carregar?
É para a internet, porque a gente teve umas dificuldades na sessão anterior, sabe, Camila? Eu acho que para a internet, enquanto as pessoas estão falando, vamos deixar só ela com a câmera ligada, né?
Eu vi alguns casos até que as pessoas apresentaram com a câmera desligada também.
Isso,
né?
Isso aí depende um pouco da pessoa, porque às vezes a pessoa tem timidez e prefere apresentar com a câmera fechada, né? Assim, isso você fica à vontade, tá?
Não, mas se suportar o sistema, a gente vamos nessa, né?
Isso, eu acho que em consideração aos outros, assim, quando eles estiverem falando, a gente tira, né? E depois, quando for a nossa vez, a gente coloca.
Uhum.
Okay, I think that we can start, if you agree.
Yeah.
Because we have all the speakers and we are here ready to start the round of presentation. So again, we promote this workshop together with Ana Clara and Michele in order to have a qualified place for discussing our application and our experience with GeoDesign. We discussed those applications in a very broad sense. It means that any scale, how may I say, any case study dealing with students, dealing with real stakeholders in designing strategic development plans or any other territorial design is relevant in order to share information and in order to discuss our specific experience with GeoDesign. Last year, the group promoted by Ana Clara, the participation of Brazilian research units was very wide. This year we balanced a little this over participation of Brazilian research group, and we are very glad today to introduce this group of speakers. Okay, let's start. I have on my phone the title. We have Francisco that will present. No.
So like there are two Franciscos here. Like which one? Like
Francisco, you can turn on your microphone. You can share.
Yeah, I need to give moderation to.
I believe Michele is going to moderate the session. My name is there, but as I am presenting today, and he is presenting.
Like for them to present, I need to give some rights.
Okay.
Like that's what I'm saying. Like
okay.
Okay.
So Francisco is okay?
No, we cannot.
We cannot hear you, Francisco. Your microphone is muted.
You are muted. Chico, you are muted.
We still cannot hear you.
Chico, when you get into the room, you must authorize your microphone or your camera. If you didn't do this, you can go to the settings.
Well, let's go with the second paper. In the meantime, Francesco will try to go out and reconnect in order to be ready. So the second speaker is Camilla. Okay, Camilla, you can turn on the microphone and you can share your screen. And the title of the paper is Geodesign in Regional Green Infrastructure Planning. A very interesting theme that we discuss also in our research. Please, Camilla, you can start.
Well, first, I'm Rubens. I'm going to present the work together with Camilla.
Okay, perfect.
I'm going to start the presentation. Let me see.
Rubens, we see your screen. Okay.
It's okay?
Okay, perfect. You can go.
Well, good afternoon. My name is Rubens Amaral, and together with Camila, we are going to present the work Geodesign in Regional Green Infrastructure, which is also authored by Maria do Carmo, which is my tutor in my thesis project. The present work is based on the research developed by the Urban Environmental Management Group of PPGFAL UNB and supported by the UFMG Geoprocessing Laboratory, GeoPrea. This articulated the knowledge to develop solutions anchored by the design tools that act assertively in the territory in the face of the problems of depletion of environmental services in urban areas. It is also the first initiative in geodesign for Distrito Federal. Brasilia is a city with 8 to 85% of permeability and arboreous and shrubbery vegetation cover around 72 square meters per habitant. But when the rainy season comes, we can see this scenario, the city's low resilience with loss of drainage ecosystem services and several parts of the city severely flooded. So the objective of this research is to identify different performances of vegetation in relation to support ecological processes, while discussing more assertive interventions in green infrastructure and restoration ecology. We count with the conceptual support of remote sensing, restoration ecology, green infrastructure, and geodesign. Our case studies Distrito Federal, a federative unit of Brazil, which houses its capital, Brasilia, in the center-west region of the country, with an area of 5,708,000 square kilometers. We use a Landsat 8 scene from the year 2020 in the dry seasons when the vegetation is most stressed. So green infrastructure as an intervention approach in the landscape can be seen not only for the conservation and for restoration of biophysical system, but also as an agent of landscape transformation, a system different from the previous one, more resilient. Green infrastructure must provide ecosystem services which are underpinned by the input of energy, water, carbon, nutrients, and biomass in the landscape through ecological support process. Pursuing the measure of support ecological process in the landscape, we applied the two multispectral index to our satellite imaging, one related to the energy and carbon inputs, CO2 flux or carbon flux, measure the carbon flux and the photosynthetic efficiency of vegetation, explain around 96% of the photosynthesis process of the leaf. The other related to water input, TWI, Topographic Wetness Index, measures the trend of water distribution and accumulation in the landscape according to the topography influence, using catchment areas of the upstream watersheds, drainage directions, and slopes. We must highlight that both indexes are proxies of soil moisture, photosynthetic efficiency, presence of organic matter in soil, among other indications of the presence of the support ecological processes. With this approach, we developed a map of ecological restoration potential, crossing areas with higher topographic wetness, with the variations of CO2 flux in the territory, resulting in areas with ecological integrity, areas of adaptability, and areas of transformability, according to the work necessary for the recovery or introduction of ecological support process. So we came to this question with the association of CO2 flux, TWI, and demands for ecological recovery, how to propose a design for a regional network of green infrastructure. To achieve this object, the resources of Agile design were used to study complex aspects related to the architecture of the landscape through the organization of a workshop called Regional Green Infrastructure for the Federal District, IVRDF, carried out with the support of the Brazilian Agile design platform, GISCOLAB, the main resource to support the work. Now I invite Camila to continue the presentation, explain the designing and development of the workshop.
Well, our workshop preparation took around 2.5 months, and the map set proposal was built dividing the layers into 39, and the layers were divided into 6 categories. Some of the most complex layers are shown in the slide. They belong to the ecological support processes system. And some layers shown in this slide are CO2 flux, TWY, and ecological restoration potential. Next slide, please. Here we can see another example of 2 layers prepared for the map set proposal. We are seeing here the connective layer and also the connective potential layer. Next one, please. We invited 24 guests to join the workshop. The workshop was held online, and we used Zoom for the meetings and GISCOLAB for developing the designs and the discussions. The guests were academic experts in landscape planning. They were also technicians from the government of the Federal District, from the environment planning area, and also from urban planning area. The participants were divided into 3 mixed groups. Each one of the groups had 8 components. We divided the workshops in 3 sections, and that were developed in over 3 weeks. We had some days dedicated to studying the area, the territory, and also to develop the design. We had group design, and we had also the individual work based on gel design too. Next slide, please, Rubens. Talking about the framework, it is important to highlight that the first workshop section was about leveling the basis of methodological information, as well for the members to get to know each other. After that, the participants were divided evenly into 3 groups, as we can see on this slide. The group, A group, B group, and C group. That worked in 2 sections to develop design proposals. Concerning the framework, the GEL design proposals followed 4 main axes: leisure and culture, provision, green infrastructure, and blue infrastructure. Thus, the proposals could be composed either of programs or projects following the GEL design framework. Proposals should be also divided into 4 subsystems, as we can see in the picture. First, leisure and culture, provision, green infrastructure, and blue infrastructure. In addition to that, participants should confirm while designing through widgets, which are present in GISCOLAB, whether they launched proposals would affect positively or negatively the following well-being constituents. First, safety. Second, health. Good social relations. And the basic material for a good life, as we can see on the slide too. Next one, please. So in this slide, we are seeing a proposed summary for the general understanding of the designs of the 4 overlapping subsystems in the Federal District territory. And we can see that maybe we arrived at many consensus, but we highlighted, as we are going to show now, some what we called unexpected designs. The highlight indication at the upper part, at the top of the slide, is a connection between Brasilia National Park and the Águas Claras Ecological Station. At the bottom, on the left part of the slide, we are showing a highlight that indicates a green corridor towards southwest. As main results and discussions, we highlight that the use of geodesign methodology in the planning and design process of regional green infrastructure network enabled through the synthesis of the adopted layers of information, the construction of a collective perception about the potential and territorial conflicts regarding its implementation. It was very important because we had many technicians that are in real life, taking part in the build of the PDOT, the urban planning systems and designs for the DF. Geodesign also helped to bring out the relevance of layers related to supporting ecological processes and landscape ecology in design. The consensus worked out during the discussions throughout the workshops, as we could see on the last slide, and it made it possible to take a first step towards sketching would be a regional design for the territory studied. The consensus also indicated the priorities for designing the project. The results of the workshop, although partial, point out some structuring basis of a more resilient occupation for the DF and can contribute to the revision of the PDOT DF that is now under discussion. Finally, we can highlight that the discussions on the matrix of ecosystem service that are now under discussion in DF established the direction for the consideration of the regional scale in the analysis and the demand for the design of green infrastructure. Well, we thank everyone who contributed on this work, and we thank also those who are watching us here today. Thank you.
Thank you, Camilla. Thank you, Ruben. Okay. We have time for a very short question. Michele raised his hand.
Thank you, Camilla. Ruben's a very interesting case study. I'm curious about the reason why you have a 4 types of participants, right? From academia, from the state and from outside, and from federal government, and another one that I don't remember. So I'm curious to know, why did you create a mixed group, and if this choice was successful eventually? From the conclusion, I can guess the answer, but I would like a little bit to know more about the reason for this choice of setting the group this way.
Okay, please.
We selected this group because what can say, landscape architecture in Distrito Federal is an aspect of difficult assimilation. It's new, it's a new stuff, and we decided to get to some academic researchers that knows and have some experience, academic experience in this field. But we needed 2 kinds of academic researchers. One that knows what is happening here, but we decided to have academic researchers that does not know Distrito Federal, is to make some kind of improvement of new ideas from a different system. But as you can see, this regional green infrastructure is a demand for the regional planning in Distrito Federal, and we asked some technicians for urban planning and technicians from environmental planning that not always are in consensus to join the group and discussing with the academic technicians. And so we decided to join them in 3 groups to make an improvement for the discussion with a lot of perspectives and different perspectives from what could be a regional green infrastructure network.
Okay, thank you. Just a curiosity, no? About the unexpected design. Was unexpected, and so it generates conflicts in the negotiation, or was unexpected from a technical point of view or from any perspective?
Well, it's basically from a technical point of view, because, for example, this there is a problem where there are 3 spots, national park, the ecological station of Águas Emendadas, and there is another one in the bottom of the scene that is Botanical Garden region. There are reserves of the Cerrado biosphere, and there is a need for connect them. But we have a huge spot between the national park and the Águas Emendadas ecological station that is not in the it's there, but it's not in the regional planning. In the regional master planning, it was not considered in the how can I say, instrumentos, legal plans.
Instruments or parameters.
Exactly. And the southeast, and the southeast connection was also something that came through the workshop, because it links a very important area that we call Área JK. That is between 2 main cities, and that is Ceilândia and Samambaia. But also with this link, it would improve in the connections and the biodiversity of this area. One of the proposals also was to improve the vegetation areas between these cities. So, but it was never conceived that we could link this area in this vector.
Okay, thank you. Thanks. We move to the next presentation. Let's try.
Camila asked you to include a few words if she can.
Oh, yes. Yes, please.
Yes, just a few words. Is that talking about the territory? Brasilia, almost all the time, is studied about concerning the local urban planning, historical heritage, and local parameters. So we thought that something interesting about this workshop is that we were considering Brasilia, but in a regional perspective. And geodesign helped to how to say that, to study and to see the layers and the conflicts, as you saw and you mentioned, and it was very interesting concerning the regional environment of Brasilia, which sometimes is not considered. And it's very important because Brasilia is just a part of a big context. So it was very interesting also. We didn't mention this, but it's something that must be highlighted too, concerning the workshop and the choices.
Okay, well, very good, thanks. Let's try again with Francisco, if it works. Francisco, let's try to... We cannot hear you, I believe. Still muted. It's still muted, yes.
Chico, can you try?
We cannot hear you, Francisco. Okay, let's go on with other presenters, and I hope that we will solve the problem by the end. I suggest to go out from the...
He's trying.
He's trying, okay.
I think that the cursor is from...
Can you guide him?
No. The cursor is on the monitor, it's from Chico, right?
No,
No, like I'm controlling now.
Francesco, I suggest to go out from the chat and come inside again, allowing your computer audio to operate. Okay, Anna Clara, I suggest to go on with your presentation. We have
yes,
the
I
video.
sent the video
Yes,
to me.
we have the video. We have the video ready here. So we have.
Can you share it for me?
Yes, yes, we are going to share it. Geodesign in
Okay.
Salvador Metropolitan Region, regional planning based on a reproducible and defensible criteria. Okay.
Perfect. I'm singing it. Yes.
Okay.
Okay, I'm starting.
Yes.
Good afternoon, colleagues. Good morning from Brazil. I'm Professor Ana Clara Moura from Federal University of Minas Gerais. I'm presenting the case study Geodesign in Salvador Metropolitan Region, regional planning based on reproducible and defensible criteria. I developed this work together with Christian Freitas and Professor Susana Cavalcante, she from Federal University of Bahia. It is part of IGC, International Geodesign Collaboration 2021, to which a huge group of universities all over the world took part. They proposed us to work with the scenarios of 2035 and 2050, according to the profiles or the behaviors of early adopter, late adopter, and non-adopter. They also proposed us to work with a collection of systems, and we could include two new ones, and we included carbon credits and tourism. And they also asked us to consider the Sustainable Development Goals while proposing the ideas. In Brazil, we were 14 universities working in 13 case studies, and Salvador Metropolitan Region was the last one developed. We were two groups from the Federal University of Bahia, Salvador, and the Federal University of Minas Gerais. So we composed two groups, a group of people from the place and the other participants not from the place. We worked in 4 days, divided in two groups, considering the dates of 2035 and 2050, and considering the behaviors or the profiles of non-adopter, late adopter, and early adopter. We use it as platform GIS Collab, that's a Brazilian geodesign platform. This platform was initially developed by a group called GE21 Geotechnologies, based on a geographic database, a geoserver, a geonetwork, and a web map. And in this web map, we optimized its use by scripts and programming to transform the platform into geodesign needs. When I say I say the Geoprocessing Laboratory from Federal University of Minas Gerais, represented by Christian Freitas and me. To the case study of Salvador, we composed a collection, a set of 40 layers divided into the 10 systems proposed. As examples, healthcare distribution, accessibility and capillarity, surface temperature, slope, NDVI, that's the distribution of vegetation cover plots, land use land cover, distribution of sewage, water, conservation units, and so on. In the first day, we proposed people to read these 40 maps, and they do the reading enrichment, in which they enrich themselves with information about the place using these 40 maps, but they also enrich the system, adding additional information that we didn't have in the collection of maps. So they used a proposed color code to do pins that are annotations about the place. In days 2, 3, and 4, we do the creation of ideas using dialogues. They are supposed to draw lines, polygons, or points, to write a title of the idea, a description of the idea, and during the negotiation, they write discussions and comments about the idea. Based on this information, people do the votings, if they like or don't like the idea, and we arrive to the final proposals. Here you're seeing the scenarios, the proposals to 2035 and 2050, according to early adopter, late adopter, and non-adopter scenarios, and using the color codes proposed by IGC. We created some widgets to measure their performance and to give support to the workshop. Here I'm presenting a widget to analyze the contribution to carbon credits, the sequestration of carbon. In the case study of Salvador, they arrived to more than 32% of increasement in carbon credits. We can have the number of trees that they are able to plant in these new areas, the new area proposed, and the carbon credit sequestration above ground and below ground as a result of their performance. IGC also asked us to measure the contribution to the Sustainable Development Goals to each scenario. So we created a widget to give support to it, because while creating the idea, the author must inform us about to which SDG he is contributing to. And we have a dynamic histogram that measures the distribution of the ideas according to the Sustainable Development Goals, and we can measure to each Sustainable Development Goal the ideas are contributing most. As I said, Salvador case study was the last one developed. In the previous workshop that were Belo Horizonte, São Paulo, Florianópolis, Rio de Janeiro, Fortaleza, Campinas, Belém, Goiânia, Recife, Macapá, Palmas, and Carbonífera, people had their own way of contributing, their own way of developing the workshop. And the main characteristics of Salvador was a process adjustment, as we could learn from all the previous case study and we could arrive to a better condition during the workshop. We call this condition of work in Brazil scalability and adaptability, because we could develop together 30 case studies in parallel, and we had the concept of adaptability to allow people to work with their way of thinking. In the case study of Salvador, in step 1, they did the reading enrichment. As I said, they were divided in group 1 and group 2, people from Salvador and not from Salvador. In reading enrichment, people not from Salvador did a very good interpretation of maps and digital information in the web GIS. While people from Salvador, they presented additional information about local characteristics that we didn't have. They together composed a mosaic of interpretation about vulnerabilities and potentialities of the area. In step 2, that was the composition of ideas, the proposals, people not from Salvador, they presented unthinkable innovation. They were less traditional. And people from Salvador, they presented ideas to everyday needs. They were more traditional, but they working together composed a mosaic of proposals about needs and possibilities. In step 3, we had the votings, in which people had to select the best ideas according to what, where, when, and why. And we asked them to consider thematic, locational, and priorities assertiveness to do the voting. When we analyze the result of the workshop, we see that they had a very good performance according to assertiveness. We asked people from the place to help us in the analysis of the results. And we analyzed that more than 67% of the proposals were considered very good because they presented the 3 conditions of assertiveness: thematic, priority, and location assertiveness. While around 33% of them were considered good because they had 2 conditions of assertiveness, and only around 9% of them were considered not good ideas because they had 0 or just 1 condition of assertiveness. When we analyze the assertiveness according to the axis of thematic, priority, and locational, we see that thematic assertiveness, thematic feature, was the best one. It's how it was according to the systems proposed. While priority 1 was how important the idea was according to the needs of the territory. As example, the idea is very good, but not for this year. The idea is very good, but it's not a priority. So the people from the place helped us to analyze it. And the location assertiveness was according to the position of the idea, because sometimes the idea is good, but not in the right place. The locational one was the one that had the condition of less assertiveness. But even it was more than 73% of assertivity. So we say that we arrived to a very good result in the workshop. But the results are not just getting to a yes. I'm presenting the idea of Friedman's, in which he says that planner's goal cannot be limited to getting to a yes, since planning is not necessarily a decision, as it can also be a starting point for building opinions. And it's very similar to the idea of Forrester when he presents the idea of transformative learning. So we believe in transformative learning, a support to opinion making, a planning based on reproducible and defensible criteria, as we believe in real inclusion and interest from people that take part in the workshop. We don't want to force them to get to a yes. We believe in adaptability and flexibility. We believe that they must feel comfortable to take place, to be part of the workshop. And if they get out of the workshop with new ideas of the place, understanding more their place, it's also a result. I thank you, and I put myself at your disposal to any further information.
Thanks, Ana Clara. Thank you for...
Thank you.
The video works very, very well. Any
Yes.
comments from the audience? Michele comes here.
Ana Clara, you did an amazing, you and all the colleagues from Brazil, but under your coordination and leads, did an amazing job with GIS Collab and all the IGC project. From the map you showed today from Salvador, you mentioned that GIS Collab can support point, line, and polygon for design ideas. I have the idea that the participants use more point, right?
Yes.
And
yes.
I would like you to give us a little bit more detail if it is the case that point is more common choice from the participant. And also probably it is related to what you said in the conclusions that attending a workshop is not only to obtain a final decision, but also to support discussion. So maybe we don't have to be very precise, but just more or less say we want to do this about here, right?
Yes.
As you,
sorry, may I? As you saw in the previous presentation from Camila and Rubens, they used polygons in Brasilia. So we can use points, lines, or polygons. It's not the point. But in these workshops that we did for IGC 2021, I asked people to prefer points because we believe that sometimes we can have a kind of a brainstorm with people of the place or with participants, and they can feel more comfortable to give their ideas in points instead of drawing polygons that sometimes they are not sure about the dimension, how precise they must be. So it's kind of a brainstorm of ideas, and the technicians can develop more precise, more qualified polygons from these ideas. So it was a decision that we took in 2021 all over Brazil in these 13 case studies, so that people could feel more comfortable to put their ideas, mainly in Salvador, because in Salvador, half of the participants were not from Salvador. And I was quite afraid of these people projecting to places that they don't know. But as you saw, it was a surprise that they took the new ideas up to the workshop while the people from the place were more traditional. So it worked nice. The point in a geodesign workshop is to have a capacity of observing what is happening. If you can, or if you need to change any rule, because the intervention of the coordinator is very important to observe how people are behaving, because you cannot lose one person. The person must feel comfortable. We cannot lose an idea. We cannot lose a participant. So during the workshop, you must do kind of an exploratory observation and control the flux of it.
Yeah, and if I can comment back, it is actually expectable that when you have more technical people, like academics and technical staff from public administration, they are for them it's much easier to draw on a map, a polygon, or a line. And while if you have a more general kind of participant, probably if you just ask to make a point, you are in a way facilitating their active participation. Otherwise, making more complex drawing like line and polygon can in a way slow down a bit their participation. So I think this is an important lesson yes. that we can take on board.
And in this huge case study in Brazil, Michele, just few colleagues knew geodesign before the meeting. So I decided to simplify so that they could prove a first meeting, and then we could develop more complex meetings, as Rubens and Camila did in Brasilia.
Yeah, and in another way, this also demonstrates how flexible the geodesign approach can be when we do workshops. Yes. We can adapt to many different conditions depending on who is participating, the objective, and so on. Thank you, Ana Clara.
Thank you.
Thank you, thank you. Let's go on in order to respect time. And Francisco, let's try again, please. We don't want to miss your speech.
Please unmute yourself.
He's not listening. Chico, they're talking to you to try again.
Yeah. Please try to unmute yourself and share the screen.
Yes. I believe that something doesn't work. Huh?
Yeah.
Ashley, we can move to your presentation. We have the geodesign teaching experience and alternative urban parameters using completeness indicators on GISCO Lab platform. Ashley, please. We have the video. We share the video and then we go on with some comments. Okay.
Yes. Is it also here?
Yes. No, the previous one.
It's Ana Clara.
I have just one video.
Just one video.
Michele.
Yeah, Ana Clara.
No, Ashley.
Ashley is sharing her video.
She has the video. Okay, perfect. Okay.
Hello, everybody. I am Ashley Adelaide Rosa, a doctoral student in geography at the Federal University of Minas Gerais, supervised by Ana Clara Moura, professor. Today I will present the paper Geodesign Teaching Experience and Alternative Urban Parameters using completed indicators on GISCO Lab platform. Authored by my supervisor, Ana Clara, the undergraduate student Beatriz Maria Fernandes Araújo, and myself. So, the current scenario is transitory and very important for think urban planning. So, it reflects a city planning that favored the motor vehicle in detriment of human dimension. In other words, the place for people became places for long congestions, parking lots, pollution, and urban sprawl. I'm talking and want to talk about the streets, public spaces, and where people see another people and where the urban life happens. So some concepts like complete streets emerges to expand this focus of street design from the automobile to safe accommodation of all modes of travel and users. So in this context of needs to change of traditional parameters planning to alternative parameters, we have the completeness index for complete streets. This index wants to support planning, incorporating more street functions, the movement function, environment, and place. So this complex context of planning may be supported by Agile design methodology. The Agile design favors the dialogue into different actors, collaborative planning, and collaborates for constructions of knowledge and citizen awareness about the place. So plus this, Agile design finds more strength when it appropriates of Agile information technologies, such as GISCOLAB, the Brazilian Agile design platform developed by Moura and Freitas. So with this panorama, this important element for this paper, the objective of this work is to present a didactic and methodological experience with Agile design as a projective proxy using a web-based platform, the GISCOLAB, and moreover, the paper presents the use of alternative parameters, the completeness indicators, in a course about urban local planning. So the students learn the process of collective construction of ideas while being informed about values that favor the condition of completeness of the collective urban space. So when, where, with who, and how this experience happened. And the activities carry on January 20 to February 8 to this year, totalizing 6 meetings in synchronous and asynchronous way. The studio area was the Pampulha district, located in Belo Horizonte, capital of the state of Minas Gerais, Brazil. Pampulha is an area of important conflict of interest between economy, landscape, and cultural values to handle in planning. So, as expected from academic activity, the workshop involved undergraduate students in architecture and urbanism of the Federal University of Minas Gerais in a course about local scale urban planning. And how the experience used GISCOLAB, the Brazilian Agile design platform, that presents a map collection, layers, and tools to assist in the visualization, analysis, and propositions of ideas for a given place. The workshop followed some steps and sub-steps. There were previous activities focusing conceptual lessons about traditions and non-traditions urban parameters, and also about completeness index for complete streets and the functions of the streets. So in the first step, an introduction to the Agile design and GISCOLAB was given. The enrichment about Pampulha was done individually, and the students were divided in 3 groups: environment, movement, and place, for work and different working windows at the platform and make the first design suggestion. And in the second step, more detailed, the student receives assumptions about the 12 indicators of completeness of the streets and made a design review, included the completeness indicators. The groups work in a psychological pass through the three contexts, ideas and comments, and then they negotiated and voted the final design. In the development of the workshop, day one, the first meeting, the students performed the reading enrichment, exploring the maps available on the platform. In addition, notes use the annotation to get from the maps or previous knowledge about the Pampulha. And day 2 and 3, the students use the dialogues tool that's enabled to insert the authorship and the idea proposed description. The students work into elaboration. Ideas began through urban parameters, represented by polygons, and urban drawing, represented by points or lines. Each group in its own context, the work windows, at just Collab. At day 4, in the second step of the workshop, after the completeness indicators assumptions, each group in its context of origin edited the initial proposal, analyzed one by one, and informed in their description each indicator the idea could contribute positively or it could cause negative impacts. For this description, the student followed the logic. Proposed name, dollar symbol, positive indicators number, and negative indicators number. And then in the day 5, after this detail, students use the dialogues to write comments for each proposal as a discussion or debate. For example, if they agree with the idea, location or not, what could be improved, and suggestion in general. And also following a cycle logic for this activity. At the end, the group entered into the on its context, analyzed the comments left by colleagues, and adjusted the proposal that it's considered pertinent by the group. So in the day 6, finally, the proposals were added together in the same context called synthesis. This context, the objective was to analyze the proposal made, their comments, and keep in mind the votes, the individual opinion. The result was one co-creative design. The workshop results were organized in an impact metrics and present for the students. The goal was to understand if indicators were more contemplated or not in relation to other functions. As can be seen, the indicator permanent spaces was the most contemplated. That's it, with more positive impact. On the other hand, the road capacity was the indicator identified as a negative impact at the end of the experiment. This panorama showed it was easier to the students to understand and create a proposal about place, to the treatment of proposals about environment and movement functions. So the performance of the proposal was also evaluated, considering thematic, location, and priority assertiveness. From this analysis, it was possible to observe that most proposed activity 3 or 2 criteria, some more than 93%. These first impressions show that the dynamics and methodological process incorporated in the workshop fulfilled its teaching and consensus builder objectives. Finally, when the assertiveness of the criteria is analyzed individually, priority assertiveness was the least recurrent, followed by location assertiveness, while thematic assertiveness was the predominant one. At the same time, this picture shows that a more deep approach concept can improve priority assertiveness, and that geo-visualization tools and geotechnologies may have contributed positively to the understanding of the place, that's it, to the location assertiveness of the proposal. So some highlights and conclusions. Geo-visualizations and geoinformation played an important role in this experience. It was carried out entirely remotely, online. In addition, the use of digital tools facilitated the communication and consolidation of main concepts. The use of geoinformation technology, such as JustClap digital platform, was shown that they have great potential on teaching. The use of completeness indications in your planned courses encourage students to research innovation and other projects for reference. That's it, to think about professional practice behind what is posted. And finally, the use of geodesign as a methodology for teaching architecture and urbans prove to be a progressive process of building consensus and new knowledges. The authors thank TNPq, FAPEMIG, and graduate program in geography for the financial support. And thanks all for the attention.
Okay, thank you. Thank you, Ashley. Any comments, any questions? Ashley, please give me your point, or I ask also to Anna Clara another way to clarify some aspects. I was curious about this concept of assertiveness that you mentioned, and probably is a part of the evolution of the methodology that you are implementing also in the GeoDesign Collab, no, GeoCollab. And similarly, I've seen also some differences between the GeoDesign Hub that we generally use in past about the impacts metrics that are measured according to, in your case, to 3 domains of connection of the single projects and so on. So please, can you give us some details about that?
Anna, can you help me to answer this question?
Yes. Ashley has COVID. That's why her voice was a little changed, because she has COVID these days. So I'm helping her. Francesco, instead of using the way that GeoDesign Hub generally calculates the impacts, we decided to measure the performance of the ideas. For example, we can construct a widget that's a pop-up frame with scripts to measure whatever we want. In the case study of Salvador, I constructed this pop-up to measure and to present an histogram about the contribution to sustainable development goals. So while creating the idea, the author of the idea has to inform us to each sustainable development goal or to a collection of goals he was contributing to in positive way and also in negative way. In the case study of Ashley, instead of measuring sustainable development goals, we were measuring indicators of completeness of the street, because we were talking about a local area and we want to improve the quality of the area and the streets of the area. So while proposing policies and designs to the place, they had to inform us if they were contributing or if we're guided by an objective to be solved. So we are measuring it dynamically. So it's based on the web processing service, because while the person is drawing, the system is automatically calculating and presenting in graphics, in numbers, in percentage, so we can choose. And according to the workshop, we can construct a specific widget, because the system is very rich, it's based on open source. So the person have to have an idea of how to measure, and we must create a script about it and create a web processing service that can be a dynamic calculation and dynamic geovisualization of the result. So during the workshop, the person receives the information that he's not contributing to the Sustainable Development Goal number 3, and he can think about it. Or the completeness indicator number X, and he can complete his ideas. So it's more or less based on this. We are testing. We have an exploratory work to test the things.
This flexibility seems to be very promising, for the...
Yes. Okay. The person just have to arrive with an idea about how to measure. And we construct the script to transform this idea into an application, into a tool.
Okay, we got also the opportunity to give some details about the new platform. Francisco was there. Oh, okay, something.
Yes, Chico, I believe it's going to work.
Okay, it works. Francisco, it seems to work. Please speak and.
Chico, try to speak, please.
Okay. Please make sure that you gave permissions for microphone. Maybe try connecting from Chrome, because sometimes Firefox can give problems.
I was with him in the mobile because he believes there is a kind of a block in his university that's not allowing him to connect, because he changed computers.
Okay.
Yes, he changed computer.
We understood he changed the computer. Okay. Yes,
he changed the computer, and Chico, instead of using the internet from the university, can you try to use your 4G or your mobile?
The mobile connection, probably.
Okay, he tried Chrome, Edge, different computer, but it's not working.
Yes. To share your 4G in your mobile to avoid the network from the university because it's blocked.
Yeah, okay. He's here, but he cannot share apparently.
But also we cannot hear you, Francisco.
Yeah, we cannot hear. And
you can present the PowerPoint without audio, just give an idea of the study, or you can switch to Wednesday.
Of course, we can try to have the room for his presentation in the next session. We don't want to miss for technical problems. It's a pity, no?
Support from GC.
If you decide about a date and a time, I can write him here because I'm here with him in the mobile, but he's not arriving there. So I can tell him another
at 3 p.m. At 3 p.m. In the session at 3 p.m. Okay, let's have this agreement, and we will try to manage in this way.
Okay, and if you can also chat there.
Francesco, you can also send a video to be sure that finally we can manage the situation. No? short
I can
video.
ask him to record a video as we did and to send it.
Yes.
So
just
if something happens, because he's calling here.
Okay. So any other comment? We have some minutes, some additional minutes to have some. Anna Clara, I have a question. I seem to understand that in your case study, finally you decided to vote about proposals more than to go in a negotiation process. I understood right? Yes.
Not exactly, because
okay, please.
yes, we do what we call changing places, like this. I have the, for example, just an example. I have the context of environment, I have the context of social, and I have the context of economic. For example, if I want with the sustainable values, then I ask group A to go and design ideas to economic or to social or to environmental systems. Then I ask group B to do the same, and they work like this, going to the context and designing ideas. Then I do another round in which people go again to the context and read the ideas that were designed there and write comments. They write comments instead of doing the comments just talking, because in the group they talk, but instead of just talking, they write the comments and they question about technicians, about possibilities, about prices, about localization, and so on. So they do dialogues, but written dialogues. And they change places like this. The groups change places and write these comments in the platform. After writing the comments, and after that everybody had written their comments and had read their comments, and then they go and vote. And the vote is individually. Because I can be with a group, I can act as a group, but while voting, I am a person, I am an individual. So they go and they vote, so the number of votes are according to the number of people that are taking part. Did you understand it?
Yes, I understood. And finally, you have a list of projects ordered through the total number of votes.
Yes.
The list
yes.
of, and
yes.
there is a threshold that means something is inside and something is outside. Some reasoning.
Yes, and after that, Francesco, I can also decide as a coordinator if I'm going to do like this. More than 50% that people said like will go to the final result. Or I can do like this. More than 50% are already in the final design, but those from 30% to 50%, I will put under discussion again. And then I open to discussion again. And people go there to do adjustments, to do some changes, and to write something more. And then I put to voting again. So it's according to the coordinator to do this. But the difference is that the dialogues, the discussions, and the negotiation are not only verbal. They are also registered. They write.
I understand the importance of this.
Yes.
Okay, thank you.
Okay, so Francisco left the room.
Well, I believe Francesco will be able to.
Okay. We took the decision to move him to the next session. So I believe we can close this this discussion. Thanks to all of you that participated remotely.
Yes.
See you on Wednesday, because Wednesday we
yes, Wednesday we will continue.
And
Francesco and Michele, thank you for the session.
Anna Clara, thank you too.
The camera, we cannot turn the camera, but we have quite a big group of people attending the session, so thank you also for them to come to our workshop.
Nice.
Okay, bye-bye. See you.
Bye. Thank you, Michele. Thank you, Professor Ana Clara. Thank you, guys. Ciao, ciao.
Ciao.
Thank you.
Bene. Allora, this is yours.